Hello, hope you are having a good morning, afternoon, or evening, whatever is applying to you. Today in this video, we are going to be tackling the subject on what a variable in algebra is. So this is for all of you people who are just starting algebra in school and are confused of why the alphabet is invading all these equations and the math that you have come to know so far. So hopefully this video sheds some light and can help you better understand the beauty and the value of variables. So variables in algebra are letters and symbols that hold a value and make sense in a mathematical circumstance. So this cartoon that I found online actually kind of shows this in a funny and very relevant way. You have this teacher telling the student that x plus 2 equals 5. So x must equal 3. Okay, this equal sign means that both sides of the equals sign has the same value or the same weight. So if instead of x, you plugged in 3, okay, so instead of x, you plugged in 3, this would make sense. 3 plus 2 equals 5. Okay, and so that's basically all variables do. They show that this x actually equals 3, and that makes sense in this case. Okay, but this kid has some concerns. He said, just a darn minute. Yesterday, you said that x equals 2. So maybe yesterday on the whiteboard, right? The teacher says that x plus 2 equals 4. Well, if you think about it now, right? If I put 3 in for x, 3 plus 2, that equals 5. That doesn't equal 4. But if I put 2 in for x, 2 plus 2 equals 4. It makes sense. So yesterday when she put x plus 2 equals 4, x equaled to 2. And that shows that the value of x depends on the mathematical circumstance. This equation shows a different circumstance than this equation right here. Okay, so we can pick up on that little concept with a few practice problems. But I do want to show you a real life example of how variables can be applied. Because a lot of times you learn stuff in math and you're just like, oh gosh, when am I going to ever use this? This is not important at all. But I can show you that it is quite important. So suppose that I am taking a road trip, which is very common. I take a lot of road trips. I like to drive. So here's my little car, and I get really lucky with traffic, and I go 60 miles per hour without being slowed or having to go faster. And I want to see how long it would take for me to travel 300 miles. Also assume that I have a bladder of steel and I don't need to take a bathroom break at all. So I go nonstop, 60 miles per hour to travel 300 miles. How long would it take me to finish that 300-mile road trip? Okay, and this is a type of problem that you'll be able to solve using algebra and using formulas that have variables. So we'll come back to this one. But this is a few problems to just show the easier side of algebra and how to just simply tackle problems that ask you to figure out variables. So like I said, variables can be any letter or symbol. Commonly, it is x's and y's, maybe sometimes a's and b's, but usually x and y's. So the first one, you have 3 plus x equaling 7. And you're asked to solve for x. Okay, so using intuition, right, you can sort of fill in the little question mark here, right? 3 plus what equals 7? So a lot of you will probably say 4, and you would be correct. 3 plus 4 equals 7, right? That makes sense. So that should be the answer. But for more complicated stuff, that might not always work. It might not always be easy numbers for you to figure that out. And for some of you guys, you might not have even figured that out, right? So like our brains work differently, and there is a more, I guess, or less intuitive way to figure this out as well. So I'm going to rewrite the problem. 3 plus x equals 7. In algebra, the main objective whenever you're trying to solve for the variable is to get the variable that you're trying to solve for alone on one side. Okay? In this case, the x is not alone. It has this really pesky plus 3 in the way of it being nice and peaceful and by itself. That's how it likes to be. But you have this plus 3. So how do you get rid of a positive 3 on this side? Well, if it's plus 3, I can actually subtract 3 on this side. Okay, so on this side of the equal sign, on the left side of the equal sign, I can subtract 3. And that basically leaves us with 0 plus x, right? 3 minus 3 equals 0 plus x. So on the left side, you just basically have x. On the right side, though, you also need to subtract the 7 by 3. And this is because both sides of the equal sign need to equal the same, right? They need to hold the same weight. So whatever you do on the left side, you have to do on the right side. Whatever you do on the right side, you have to do on the left side. That is very important. If you miss that step, you're not going to get the right answer. So 7 minus 3, sorry, is 4, right? And that makes sense. 3 plus 4 is 7. Okay, so I'm going to sort of use this strategy of trying to get x by itself on all these other problems. If this x on the left side is being multiplied by 5, right? When it's right next to each other without like a little like plus sign or minus sign, it means that it's 5 times x equals 15. So if it's 5 times x, what's the opposite of multiplication? That would be division. So 5 times x, I want to get rid of this 5. Well, I guess I'll divide by 5. Okay. So 5x divided by 5, these 5's cancel each other out, and you're left with x on the left side. Okay, so whatever I do on the left side, I have to do on the right side. And notice how I'm not dividing 15 by 15. It's not that I'm dividing, like, I divided the 5 by 5 to get x by itself. But since I divided this left side by 5, I have to divide the right side by 5. I see a lot of students accidentally dividing by 15 because they think they just need to like cancel everything out. No, just cancel out the stuff that gets you x by itself. So 15 divided by 5, in this case, is going to be 3. So your x is going to be 3. This makes sense because if you sort of put 3 back into the original equation, you get 5 times 3 equals 15. Makes sense, right? Okay, in this case, you have 19 minus y equals 8. Okay, I want to get y by itself. So I could probably subtract 19, right? There's a 19 here, a positive 19 here that is being a little pesky. Okay, so I'll subtract 19 on both sides. Cancel this out, so you're left with minus negative y equals minus 11. Okay. And so yeah, this is just a little bit of negative. You don't be afraid of the negative sign. You just have to make sure that you keep track of those negative signs and you don't accidentally lose them. Notice how since that you started with a minus here, 19 minus y, this minus doesn't go away. All you did was cancel the 19 out. This minus is still here. So it becomes a negative y. Okay, when you have negative y equaling negative 11, that's actually the same thing as saying negative 1 times y equals negative 11. Okay, so this little negative 1 is being a little sneaky here and actually attaching itself to the y. We want the y by itself, so I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 cancels each other out, so you're left with y on the left side. And then on the right side, negative 11 divided by negative 1 is positive 11. So you put that there. This makes sense. If you plug it back into the regular equation, 19 minus 11 is 8. Okay. So now we actually have some extreme questions. Okay, that's a little silly, but these are a little bit more challenging, I would say, especially if you're just starting with algebra. but it is definitely doable. So we just have to sort of keep the idea of getting x by itself. So in this first case, you have a fraction, and fractions are really just division, essentially. You have x over 3, so this means x is being divided by 3. So x divided by 3 equals 4. So what's the opposite of division? Multiplication. Okay, right, so I want this x by itself. I will multiply both sides by 3. I'm using a dot because I don't want to, I know a lot of times people will be like 3 times 4 equals 12, but in algebra this times sign looks like the x that we use for variables, so it's better practice to use this dot. So I'm multiplying this side by 3 to cancel the x divided by 3 bit. Whatever I do to the left side, I have to do to the right side, so I'm going to multiply the 4 by 3 as well. So I'm left with x equals 12, right? That makes sense. Okay, so this is b squared, b to the power of 2 equals 25. If you're not familiar with exponents, don't worry, not a lot of people who just start algebra are. I'll make a separate video on that for sure. But basically, the opposite of squaring is a square root. It looks something like that. Okay, it's definitely on your calculator. If you're using a calculator, you can sort of just plop it in. But if you already know your squares chart, you probably, I'm sorry about that. You probably know that the answer to this would be 5, because 5 squared equals 25. But if you didn't know that, you can just use the little root sign. So the square root of b squared, this really cancels out the squaring. It's just b. And then the square root of 25, you can pop it in your calculator. You can just look at a squares chart. It becomes 5. Technically, though, it actually becomes plus or minus 5. That's a little confusing. So I think I'll definitely touch on that in a later video where we maybe get into like more quadratics and stuff like that. But for the most part, I think you guys get the idea. So I want to go back to this problem, and I'm going to work it out really quickly. I just want to show you that variables can be useful. For this type of problem that relates to distance and rate and time, I was taught to use a formula called, oh, sorry, that's a terrible D. Let me rewrite that. I was told to use a formula called the dirt formula. Basically, the D stands for distance. I guess I'll write that down. Distance. The R stands for rate. T stands for time. So you sort of fill out what you're given, okay, what you know. So I know the distance I'm trying to travel. I'm trying to travel 300 miles, right? So my D is 300. What is my R? What is my rate? Well, my rate is like anytime I see a per or every 60 miles every hour type of thing, that's a rate. Okay, so in this case we have 60 miles per hour. So my rate is 60. Okay, and do we know how much time that I've driven for? No, that's exactly what we're trying to solve for. So we leave that t as t. And this is the variable, this ends up becoming that variable that we're trying to find out. So like we did with the other examples, right? I'm trying to get t by itself. I'm trying to get this by itself. So if it's 60 times t, what's the opposite of being multiplication? It would be division. So the opposite of 60 times would be divided by 60. Okay, cross that 60 out. Whatever I do to the right side, I do to the left side, right? So 300 divided by 60 ends up being 5. And so that's my t. So that means that it would take me 5 hours, again, assuming that I have a bladder of steel and that traffic cooperates, to finish this road trip. Okay, so that's all the time I'm going to use up on this video. I don't want it to be too long, but hopefully this helped, because it definitely is confusing to see letters in math, but definitely gets more complicated from here. But as long as you get this foundation right, it's going to be great. So make sure you practice. Practice makes perfect. And yeah, get your study on. All right.